Okay, now we'll start inputting branches and nodes inside the Energy Plus. This is a snap of the diagram. I also recommend that you also prepare this kind of diagram in any rough page. Uh, it will be helpful. So we'll start with supply side of chilled water loop. Supply side would be this one. It would have three components: purchase cooling as district cooling, baby chiller as chiller constant COP, and big chiller as electric chiller. Okay, every side, every half loop, it is recommended we should make a bypass pipe through that. Bypass is actually the path through which the fluid will flow when all these components are not working. It is also recommended that it is not actually recommended. It's said in the Energy Plus documentation that we have to make a pump on every uh, on the very first branch of the supply side. Making a pump on the demand side is not required, but a pump has to be there, and it has to be there on the very first branch of the supply side. So in here also I have made a pump. Here also I have made a pump. I haven't put a pump in demand side of condenser loop. It's not required. But as there are three cooling coils here, three HUs, I have put a pump here also. Okay, so we'll start. In the Energy Plus, you'll search by Control L, and we'll search for branch. Here is the branch. We'll start inputting branches. The very first branch would be a pump, and then would be three parallel branches of, sorry, four: bypass, purchase cooling, baby chiller, and big chiller. Then there would be outlet branch. This branch has a pump, so component inside the branch would be a pump, and this bypass and this outlet would be a pipe, because there is no component attached to it. So in Energy Plus, to transfer the properties of a fluid from one node to another, if it doesn't have any component, we can just put a pipe. uh, it's simple algorithm. So we'll start with the pump. We'll decide upon a formula, or upon a methodology to write names. So CHW for chilled water. This would be chilled water pump branch. We can put it as auto size, and pressure curve, drop curve is not required. All these objects in blue are required. In black they are not necessary. So in branch we have to input one component. This would be a object type would be a pump variable speed. There should be a drop down menu here, but it's not here. um, there are some reasons for that, so we have to write the exact name of the component. You can see pump variable speed. There are two kind of pumps. There are pump variable speed and constant speed. Variable is more energy efficient, so we'll be using that. And the name we can put, because this is supply and chilled water loop, so chw and supply pump. Okay, these are the nodes. So the starting point, this point. Now, because this is actually the inlet node of this whole loop, so we'll name this as um, chilled water uh, supply inlet node, and this we can write as chilled water supply pump outlet node. Branch control type, here we had to write either active, passive, or bypass. It was compulsory to write before um, version 7.0. Right now it's not required, so we'll leave this as. Okay, here we have just marked the branch. Now we have to make an object with the same name and these same nodes in the pump variable, in the variable pump speed object. So we'll copy this, Control C, and we'll go to pump variable speed. We'll make a new object. Inlet would be supply inlet node, and outlet would be this. This we can do auto size. It's better to auto size everything which we can do. Okay. um, what I'll do is I'll input all the other values from the input output reference. You can also do it, and you can read about every this part, minimum flow rate, pump control type, everything from the input output reference. That would be good. Okay, so we have made this branch. Now we have to make four parallel branches. Um, we'll start CSW bypass branch, CSW supply bypass branch. This would be auto size. Okay, this would be pipe adiabatic. We can name this bypass pipe, and we can give a name bypass inlet, and then bypass outlet. Okay, this is also pipe adiabatic, so we'll name this before these equipments. We'll just copy this. Supply, this would become supply outlet. Uh, this would be pipe adiabatic, and we'll remove this. Inlet, we'll keep outlet pipe inlet node, and similarly, as we had done in this pump branch, uh, the inlet node was supply side inlet node, so here it would be supply side outlet. See, in this branch this would become outlet of this whole loop. So we'll remove this outlet node. Okay, now these chillers are remaining, so we'll make a new object, chw supply equipment 1. Equipment 1 is actually district cooling. You can see district cooling is somewhere, district cooling. We'll name it as DC, and we'll name it DC inlet. Inlet node, and this has DC outlet node. Okay, now the we'll copy this only, copy paste. This will become equipment 2. This we were planning to put chiller constant COP. So chiller constant COP. We will name it as baby baby chiller. This will become baby chiller. No. This will become outlet. Equipment 3 would be an electric. So this would be chiller electric. This was big. Okay, so we had actually just made a pump. We have to make pipes also. Yeah. So these were the pipes. There was bypass pipe and there was outlet pipe. Bypass inlet and bypass outlet. Then this will become outlet. The nodes were supply outlet pipe inlet node, and this was supply outlet. Okay, now we have to make, okay, this was supply outlet, yeah. So we have to make district cooling. We'll name it DC. This will become inlet, outlet. Capacity, for now I'll put it as 90,000, 900,000 watt. This is just a random large number. Um, this is actually how much watt it can handle. Above this value, it won't purchase from outside. So we had made equipment 1. Then we have to make a chiller constant COP. This was CHW. Sorry, this was baby chiller. Nominal capacity we'll put as 25,000. The reason for this I'll discuss later. For now, we'll just keep this. We'll make it 2.5. This we can auto size, there is no problem. The chilled water node, this was baby chiller. This will become outlet node. Okay. Okay, we saw here that in baby chiller there are in a component there are inlet and outlet from the chill water loop from the supply side. Then there are nodes for condenser loop also. So here we have to mark condenser. We have to make a node here. So we'll start baby chiller condenser inlet node. This will be outlet node. Air cooled. There are three types: air cooled, water cooled, evaporatively cooled. Water cooled, we fix. We write water cooled here when we are using a condenser. Otherwise, we will make air cooled and evaporatively cooled. So water cooled would be here. Okay, about these all names, these all basin heater capacity and all these objects you can see in the input output reference. The third equipment would be chiller electric. Okay, this would be water cool, and this would be chiller. Nominal capacity, we are going to keep 45,000. COP would be 2.75. Right now I'm just writing these, seeing from input output reference. Um, okay, the inlet would become this big chiller inlet node and big chiller outlet node. Condenser, we'll use it from baby, instead of baby it would be big chiller, and then the big chiller, this will become out. I'm just writing these values seen from input output reference, so you can see from there. Okay, now we have made all the six branches of supply side of chilled water loop supply side. There are six: one, two, three, four, five, and the sixth. Okay, the branches are done, and so are the components. After branches, we have to make a branch list. So the list would is actually chilled water supply side branches. The order of the branches is important. The order here is not necessary. We can write it any order, but in branch list, the order is important because Energy Plus actually uses this branch list order to simulate the loop. So order is like, the first would be where the fluid is entering. So this would pump branch would become the first one. These four parallel can be written in any order, but these four have to be together. Then comes the outlet one. So we'll make this here bypass and equipment 1, equipment 2, equipment 3, and then would come the outlet branch. Okay, now is the now what we are going to do is, we are going to put a splitter and a mixer in this. So what are splitter and mixer? You can see the fluid is separating, it's distributing in four different branches. So this would become splitter, and the fluid is mixing into one branch, that would become a mixer. So in this splitter, we'll make a new object. This we'll write chw supply mixer. The inlet branch would be the pump branch, and there would be four outlet branches, bypass, and these three equipments. For mixer, okay, I think I read it wrong. Should have been split up. The outlet branch would be this outlet, supply side outlet branch. This would be then bypass, then all three equipments. After this, we have to make a list of all connectors. Uh, in Energy Plus, a half loop is supply or demand. Each half loop can contain only one set of mixer and splitter. That is, in one half loop there can be just one splitter and just one mixer. So we have to list it here. So this would become CSW supply side connectors, splitter, and here would be mixer. We'll just copy it. Okay, so we have actually made these this half loop, uh, chilled water supply side half loop. In the next video, I'll cover the other half. Then I'll start with the condenser loop.